All right, so some of my students have been struggling with how to change an exponential factor to the rate, so to the R value. So to start off with the equations, so the first one that I gave my students was this, where you have the initial and the growth factor. So this is initial, and this would be the growth slash decay factor. All right, and then okay, over here we got time, and we got ending amount, total amount. All right, but this is what students are struggling with when we go from that to all right, so actually let me erase this stuff in between. Grab another color. So those two things are interchangeable. They're the same. Ending amount, ending amount. Total amount, total amount. A and P, they're the same. You can even put little a there if you want to. You don't have to put P. P is just for principal, so whenever you have a problem talking about money, we have APR, annual percentage rates over time. So we usually put P there for the principal, but it's the same thing. That's the initial amount. You can put A there, little a, not capital A, but little a there if you want to. All right, and this isn't always gonna be A of T. Maybe if we're talking about a population problem, this is P of T. Or if we're talking about cost, it could be C of T. So cost over time. These are, you can change the letters, but the point is this is still total. This is still start. And this is still time, which makes a lot more sense now because it is actually T instead of an X. But that was time, this is time. The difference is this one and that one. Is this whole bit right here, that whole bit right there is B. So I'm gonna write it over here. Is B equals 1 plus or minus R. Now another way to look at how you can solve, well actually let me erase all this and give an example. So we now know that. We know that this is the general for B is 1 plus or minus R. So now let's talk about a problem that my students are dealing with. Let's say, no, actually, y equals 30 times 2.5x. And I'm asking my students, tell me what the rate is. What is R? I want the R value. What is the decay or growth rate? I want the R value. All right. So the issue with this is that's not the rate. This is in the first form that we started with. This is the growth factor. And hopefully you guys realize this growth factor is bigger than 1, growing. All right. So this is a factor, it's not a rate. So I need to change this. So that becomes A sub T, A of T. That's the initial, that's still gonna be the initial. And then that becomes T. All right, but how do we change this? How do we change this? Well, I can plug this in. I know what B is, and I have this general form of an equation. This is always true. I can plug that in. So I can put in 2.5 equals 1 plus or minus r. Well, what do? I just subtract 1. Subtract 1, subtract 1. 1.5 equals r. Now it's no longer plus or minus because this is a positive, right? We have a positive number. So this would be 1 plus 1.5. And isn't 1 plus 1.5 2.5? You broke it apart. This number is always 1. There has to be a 1 there. So it's basically, what do I do to 1 to get this old number? Well, another way to look at it is you can just plug in your b value into this general equation and solve for it. All right, you can always just plug it in there and solve for it. So let's do one where you're going to get a negative number. So literally, just change the whole thing up. Let's do y equals, start out at 200, and we're going to have a decay factor of 0.63x. All right, so we're going to change it. And actually, let's say this is population. Let's say we are on a remote island and there's only 200 sloths on the island and they're going extinct. All right, so the amount of food on the island's running dry. So this would actually be population over time. And we're gonna start with 200 of these island sloths. Now I'm gonna put the 1 there because that 1 is always right there, it never changes. And then I'm gonna put my t. All right, so I need to figure out what do I do to 1 to get 0.63, so I can plug it in. So I can plug in 0.63 equals 1 plus, when I subtract 1, I'm going to get negative 0.37. So I take that negative 0.37 minus 0.37. There's r. This is r. All right, and r equals negative 0.37, which would be a decay rate of 37%. All right, so you can use this general formula, and I wouldn't actually even put the minus in there, you don't need to. Just always have it 1 plus r, and when you solve for it, you're gonna find out, is it a positive number, am I adding it, or is it actually a negative number? And then that's what r is. Hopefully that helps my students. I know the hardest part with this, and once you get the hang of it, once you realize all this is what do I do to 1 to get this? Do I need to add something to 1, or do I need to take something away from 1? And what is it I'm adding or taking away to get that old number? If it's less than 1, obviously I need to subtract. If it's greater than 1, obviously I need to add something. All right, once you get the hang of it, super quick, just need to realize I'm doing something to 1 to get this factor. That's r. R is the thing that you do to 1. What am I decaying? What am I growing as a rate? All right, hopefully that helps. Thank you for watching. I hope everybody is doing well at home remotely learning.